Students, shall we start a chemistry class now? Okay. Today we are going to start a new chapter, surface chemistry. Thanks. Surface chemistry. Okay. So first, what is surface chemistry? Okay. So it is a phenomena, okay, that occurs at the surface. So if you take what is the meaning of surface chemistry means, it is a phenomena occurs at surface. Okay, we call it as surface or interface. Both are same, surface or interface. Okay. Now, why you are taking very important, you are showing importance to the surface means several properties of the substances. You take a substance like, okay, we know that very dominant substance in our chemistry term, we are talking about in terms of solids, liquids, and gases. Okay, those properties of the substance can be well explained, okay, depending upon the nature of the surface, depending on nature of surface. Okay, so the properties, whatever maybe if you took a solid, liquid and gases, those properties can be well explained, okay, on the basis of the surface effects only. So that only we are more concentrating on the surface of a substance. Okay, now I am going to give what is called a interface. What is called first the terms involved. Okay, what is called a interface. Okay, so interface is represented by separating the bulk phase. Okay, so it should be represented. So now I am giving first representation. So represented by separating bulk phases, separating the bulk phases. Okay, so it is bulk phases by using a symbol, by using dash, or we can use slash also. For example, if I am giving that the surface, the interface between solid and the gas, so I can write solid gas like that. Okay, so this is called the interface. Okay, this is called the interface. So represented by separating the bulk phases, represented by separating the bulk phases by using dash or a slash. So that is only named as what a interface. Okay, so especially in this lesson, we are going to talk about one new term I am going to introduce, that is called adsorption. That is called what? Adsorption. So first of all, I am going to explain. Okay, I am going to explain what is adsorption. Okay, we know already absorption. Okay, if I ask what is absorption means, that is one example, and clearly I'll explain all those by taking one example. Okay, so first of all, let me take adsorption. Okay, one example of absorption. You take duster. Okay. Duster. Okay. So you take a chalk piece powder. Okay. Chalk piece powder. So you take a duster and a chalk piece powder. These are constantly disturbing. Don't disturb the class. You take, this is your duster. Okay, where the chalk piece powder are placed over the surface of the duster. Okay, so when you take the chalk piece powder, it is not entering into the bulk. It is not entering into the bulk. Okay, but it should be present over the surface. Over the surface of the duster. This is called the surface of the duster. Okay, so the chalk piece powder, okay, that are just present over the surface of the duster, but it is not entering into the duster, into the bulk. So in interior, that is penetrating. So far we can call it as penetrating. So it is not penetrating. Okay, so it should be what? Present just like that. It should be deposited over the surface. So this is only called the absorption. Okay, so any material, if you are giving that the solid surface has a tendency to absorb those material and keep over that on the surface. This is called the absorption. Just keep it in your mind. It is not moving into the bulb. One more example, if you take a glass windows, okay, so if you continuously watching that, every day we are cleaning, even though you can touch the, that is the glass, okay, by using of your finger, you can see that some dust will be always present, okay. So this is a good example for absorption, where the dust particle, it is not entering into the water through the glass, but it should be deposited over the surface of the glass. Okay, this is a good example for absorption. Okay, now I'll give you one more difference, because what is absorption? What is absorption? We want to what? We want to verify. Okay, if you take absorption, because clearly we should understand what is first absorption and the absorption. Okay, now to explain the absorption, you take one sponge. Okay, let me have water in the bowl. Okay, so you take a bowl. Okay, into that bowl, just we are keeping water inside. Okay, just taking a bowl, and you are taking a duster. Okay, this is your duster. So if you are taking a sponge like material, so you take a sponge. Okay. Now when you dip a sponge into the water, now can you guess what happens? So it is very simple. You can say that okay, the water molecule will be enter into the sponge. The sponge is going to absorb the water. Now what happened here? The water molecule, okay, the water molecule is absorbing. Okay, is absorbing. It is continuously what? It is penetrating into the sponge, inside that sponge. Okay, so but it is not present over that surface. So anyway, the water molecule, it is moving inside the sponge. Inside the sponge means it is a bulk phenomenon. Okay, it is a what phenomena? Bulk phenomenon. Okay, so the water molecule is going to what? Absorb fully by a sponge. Okay, the water molecule is penetrating into the sponge. So this is a good example for absorption. So absorption is different. Adsorption is different. Okay, so here the absorption is what? Taking the molecule inside fully. So adsorption means that is whatever may be the molecule, it is going to be absorbed. That should be present over the surface of a material. Okay, now it is clear absorption and adsorption. Okay, now I will tell you one more example because we are reading all. First we should know what is the difference between all those things. Okay, now I will give you what is sorption. What is sorption? What is sorption? So for that I will give you an example. Okay, you take one beaker like beaker. Okay, you take one beaker. So into that water molecule will be present. Okay, you take one beaker containing water. Okay. Now, okay, you take this would be water mixed with the ink. Mixed with the ink. So this water molecule, it should be mixed with water, ink. We know that ink is a material made up of, okay, ink is a material. So where you get, where we found that water that should be add with some colorant. So specifically I will use a dye. Okay, so if you take a blue color, that will be represented as whole as a dye. Okay, now I am taking one beaker containing ink. So the ink is made up of what? Water and then dye. Okay, now I am going to take one choppers. Okay, one choppers. Okay, choppers. Now I'm going to dip into the solution. Choppers. Okay, now I'll draw the choppers like this. Okay, this is the choppers. Now I'm going to dip into the solution. Okay, now what happened? So I can clearly show like this. That is, whenever the water molecule is penetrating inside. So here the water molecule is penetrating inside the choppers. Okay, inside the choppers. But okay, if you take the ink, okay, the ink will be presented. Okay, will be present on the surface of the choppers. That's why we are showing that the blue color will be appeared on the surface. But when you look into the bulk, okay, the bulk is containing water, water particle. So here, the water particle will be present in the bulk. So this is a water molecule. So this is water molecule will be present into the bulk. And the dye will be, that is the dye, whatever may be the coloring material you are taken, that will be present only at the surface. Now we can see whether absorption is taking place, whether adsorption is taking place. Okay, now you look at this. This is telling first what is absorption. Any material that is present just like that over the surface of a solid means I can give this is absorption. Okay, clear. So any substance that is penetrating into the bulk means into the surface mode in depth, that is taken as what? Absorption. Now I am giving a different idea. Okay, that is sorption. Sorption is nothing but both. Okay, both phenomena like adsorption and absorption techniques. Both phenomena. Okay, in a system where if you find that adsorption is possible, absorption is possible, that is given a specific name, that is named as sorption. Okay, sorption. But here, if you take water molecule is moving inside the bulk, so this phenomena is called as what? Absorption, where the dye particle which is present over that surface, this phenomena is called what? Adsorption. So both phenomena occur together. So this is given a different name, that is called as sorption. Okay, so if you take that in diagrammatically also, I can represent this would be suppose if it is a solid surface, okay, solid surface, where the molecule will be present inside, okay, inside and outside also. So this is called a what? This is called a sorption. So present at the surface as well as in the bulk. As well as in the bulk. Okay, so this is phenomena called as what? Sorption. Okay, this why we are giving this absorption, and this sorption. What is relating to this our syllabus? Okay, if you take the surface chemistry is a phenomena. First of all, we know that it is a phenomena occurs at the surface. Okay, now if you take that absorption is a surface phenomena. For that only I gave an idea about what is called a absorption. Absorption is a what phenomena? It is a surface phenomena. Okay, now I'm going to explain how the absorption will be taking place and what is the mechanism and what is the characteristic of an absorption. Let us take one by one. Okay, so if you take any solid, okay, if you take a solid, now I gave a surface of the solid is like this. Okay, now if I take a surface of the solid like this, so it is not what a smoothie surface to take. Okay, this is the surface of solids. Okay. Now the solids, whenever during absorption, we should concentrate on two factors. Okay, one is we are talking about adsorbent. Another one we are talking about adsorbate, because both only acting on a adsorption. Okay. So first of all, what is adsorbent? Okay. Now if I take a adsorbent, okay. So if I take a adsorbent, the solid surface acting as a adsorbent. Solid surface acting as a adsorbent. Okay, and this what are all the examples I can give for a solid surface?
இந்த தேவையில்லாம குழப்பிக்காதீங்க. அதான் என் குழப்பமே. கனவுல வந்து தள்ளிட்டு போயிட்டானா சின்ன பொண்ணு கல்யாணம்னா எல்லாம் தன்னால சரியா போயிடும். கல்யாணமா இந்த பொண்ணு உன் பொண்ணை மட்டும் நான் கல்யாணம் பண்ணுனா இங்க வர கூட்டுறா ஏன் டீ காபி ஏன் சமோசா வீட்டுக்கு இருக்கணும் சாப்பிட்டு படிச்சுட்டு.
Okay, if I take a silica gel, okay, and metals like, if I take a metals like platinum, palladium, copper, okay, and also silver, okay, and certain colloids also will have the tendency to act as an adsorbent. Okay, so adsorbent means what? It is nothing but solid surface. Okay, and what are the solid surface? We may have silica gel, and you can take a metals like platinum, palladium, copper, silver, and you can take certain colloids also as an example for the adsorbent. Okay, now what is an adsorbate? Adsorbed substance. What is that? Adsorbed substance. That is given a name as what? Adsorbate. Okay, now what are all the substance you can absorb? So what are the substance can be act as a adsorbate? Like your gases like, okay, gases like, you can take helium, neon, okay, helium, neon, sulfur dioxide, ammonia, okay, and even solution of NaCl. Act as a good adsorbate. Acting as a what? A good adsorbate. Now there are two concepts you should keep it in your mind while you are reading absorption. What are the two? One is adsorbent and another one is what? Adsorbate. What is adsorbent? Solid surface only acting as an adsorbent. What is adsorbate? The adsorbed substance. So it is very clear. I am going to provide one solid surface and that solid surface is going to absorb the adsorbate. So if I take a adsorbate like, okay, so if you imagine that if any gases like helium, neon, sulfur dioxide, whatever may be, ammonia, okay, if you are providing that, those molecules, it is going to be adsorbed on the surface of the adsorbent. Okay, now what is an adsorbent? I'm taking adsorbent is nothing but surface of any solid. The surface of any solid, it is not a smoothie surface, so that only I gave like this structure. And where the gas molecule, it is going to be adsorbed like this. This is called a adsorption. What is this called a adsorption? Now I will tell you what is the mechanism behind this adsorption. Okay, whenever the gas molecule, it is going to be adsorbed over the surface of a solid. Okay, and what is the mechanism for this adsorption? I will give you what is the mechanism for the adsorption. Mechanism for adsorption. Okay, now you know that whatever may be solid or gases, the molecules will be present. Okay, if I assume that this is our container, okay, this is our container, I can represent the molecules. Okay, we know that this is our surface. Okay, where this is our surface. Okay, surface. So this is surface. Okay, and you assume that the molecule is present. The molecule, if the molecule is present on the surface, present. Okay, this is a surface molecule. We know that many molecules are present in the container, in the molecule, but we will imagine, okay, by taking a consideration, I will take this is a surface molecule, and next I am going to take one molecule present in the bulk. Okay, so this is present in the bulk, this is present in the water, in the surface. Okay, now what is the force acting in between these two? Now you see that in the bulk molecules, okay, bulk molecule, okay, this molecule, it is going to be attracted, okay, it is going to be attracted by the neighboring molecules in all sides. If you take that, okay, so the molecule present in the bulk, if you imagine like that, this molecule is going to be attracted by all the neighboring molecules because it is present inside into the bulk of the solution. So it should have a force in all directions. So if your force is present in all directions, means there is no resultant force here. So no resultant force. The resultant net force will be 0. No resultant force. Because why no resultant force? The molecule should be water attracting in all the sides by using of other molecule, by the neighboring molecule. If you compare with the bulk molecule with the surface molecule here, okay, the surface molecule have the attraction only like this, It is not attracting upwards. So the surface molecule, okay, the surface molecule experience only downward attraction, downwards pull or downward attraction. Okay, there is no attraction on the upside. So always this molecule, if you take the surface molecule, this is always under a tension, under stress or tension because of the unbalanced force. Why means We know that the bulk means the forces can be acting in all the sides. But if you take a surface, the force is acting only downwards. Okay, the upward there is no force. Okay, this is called a unbalanced force. So this molecule experience the unbalanced force. Okay, so because of that only, this surface molecule is always in a condition of a this surface molecule as always in continuous stress or tension. Okay, so to balance that unbalanced force, okay, now this has a tendency of attracting, okay, attracting the adsorbate molecule. Adsorbate molecule. Okay, now if you are providing the adsorbate molecule, the surface molecule will have a tendency to attract the adsorbate molecule on the surface. Okay, by this method only we can explain the mechanism of adsorption. Because what is the condition? Why the adsorption is necessary? Okay, because the adsorption is a surface phenomena. We should talk about the surfaces. When we talk about the surfaces, we should talk about the molecules that should be present on the surface, or the molecule which is present inside the bulk of the solution. Just I gave a comparison. Bulk of the solution experiences all side force of attraction by the neighboring molecule, but whereas the surface molecule experiences only the downward attraction. So this molecule is capable of attracting the adsorbate. Okay, now this molecule is what? Capable of absorbing the adsorbate molecule, and it should keep under on the surface of a solid. Okay, this is a mechanism of absorption. Why absorption is essential. Now next, I'm going to take what is a characteristic of absorption. Okay, next I'm going to explain what is a characteristic of absorption. Characteristics of adsorption. Okay, we know that adsorption is a surface phenomenon. So it occurs on interfacial angles. Okay, so I can interfaces between solid, liquid, gas, liquid, solid, like this. Okay, solid, like this. Okay, this is what a surface phenomena. Okay, so the interface you can consider two phases. We can consider solid liquid or gas liquid or liquid or solid like that. The phases will be changed. Okay, now what is the characteristic of an adsorption? Okay, now if you take an adsorption, simply you take, this is the surface of a solid. Okay, this is the, now you assume this is our surface of a solid. Okay, surface of solid. Now what is called the adsorption? Okay, adsorption is nothing but, okay, it is a process of absorbing the adsorbate molecule over the surface of a adsorbent. Okay, now you assume that whenever the gas molecule, if I take the gas molecule, it is going to be absorbed on the surface of a adsorbent. This is only called what? Adsorption. Okay, now if you take a surface of a solid, you imagine that I am going to take a gas molecule, like you imagine this is our gas molecule. Okay, for your consideration. So this is our gas molecule. Okay, now it is going to be absorbed. It is going to be absorbed on the surface of a solid. You imagine that I'm taking surface of solid and this should be acting as a what? Adsorbent. Solid surface acting as a adsorbent. The gas molecule acting as a adsorbate. Adsorbate. Now what is our adsorption? Now the adsorbate molecule is going to be adsorbed on the surface of a adsorbent. Okay, this is what we have. Okay, now the gas molecule, the adsorbate molecule is going to be adsorbed on the surface of a adsorbent. Okay, during this process, you imagine that there is always a bond is going to be formed between these two. Okay, between these two, a bond is going to be formed. So during the bond formation, okay, during bond formation, okay, we should talk about what happened to the energy. Okay, what happened to the energy during bond formation? We know that when the bond is formed means certain amount of energy that has to be liberated in the form of a heat. So whenever the bond is formed, the energy has to be released in the form of a heat. The form of heat. So whenever the energy is released in the form of a heat means, okay, so energy is released in the form of heat means this reaction comes under the category of a exothermic reaction. What type of reaction is this? Exothermic reaction. So what is exothermic? What is exothermic means? The heat is liberated from the system. Okay, this is called an exothermic reaction. Okay, so during the bond formation, we know that the energy has to be released. The energy release should be converted in the form of a heat. So this reaction comes under a what type of reaction? Exothermic reaction. So I can give you the del H. What is del H? Change in enthalpy. So this del H value I am indicating as negative sign. Why? There is loss of heat. Okay. So what is this del H? Del H means change in enthalpy. Enthalpy means heat. Enthalpy is water. Heat. Change in enthalpy. Okay. Now, first you are talking about what is the value of a del H. Okay. Del H is what value? Negative. Okay. And if you take all this absorption phenomena is a spontaneous process. Absorption is a what process? It is a spontaneous process. What is spontaneous process? We know the process that occurs as it is without any external force. Okay, the process that occurs as it is without any external force, that is given the name as what? A spontaneous process. Okay, so this absorption is a spontaneous process. So for a spontaneous process, the del G value that should have negative value. So if you take del G, change in free energy, that is what is del G? Change in free energy. Change in free energy. Okay. So this change in free energy should be a negative value. This is a second condition. And when you take absorption, now I'll explain by taking one more example. Suppose if you provided this surface, solid surface, if you are taking solid surface, okay. Now, whenever this is adsorbent, you consider this is your adsorbent, any solid surface, okay. Now, what is our aim? We are going to provide a adsorbate molecule that should be adsorbed over the surface of the adsorbent. Okay. Now, if you take a gas molecule like, okay, you imagine that the gas molecule like that it is going to be, now it is the gas molecule, it is ready to bind themselves on the surface of a solid on the surface of a solid in all directions. In all directions. Now it is ready to absorb over the adsorbent. Okay, this is before absorption. Keep it in your mind. This is before absorption. Before absorption. Now I am going to consider, okay, what is randomness or disorderness. Okay, now you see here, all the molecule it is going to be, this molecule is going to be absorbed. Okay, now this molecule is going to be absorbed on the surface of a solid. Surface of a solid. Okay, it is going to be bind with the adsorbent. But when you look at this, all in some way different direction. So what happens to the disorderness here? Disorderness. Okay. Now here, before absorption, the disorderness is increases because what is the meaning of orderness? You know, molecule is arranging like in a straight line. Okay, one another means this is called the orderness. Disorderness means it is not in an order way. So that is in anywhere, any direction. So here the disorderness is increases. Okay, before absorption. Now I will give you after absorption. So when the molecule is absorbed, okay, after absorption, you will get like this. Just the same. This is a solid adsorbent. Okay, this is a solid adsorbent, but the gas molecule, it is going to be adsorbed like this, like this. Like this, it is going to be absorbed. Okay, this is adsorbate. This is what? Adsorbate. Okay. Now, if you take the adsorbent, okay, now the adsorbent is ready to take a molecule of an adsorbent on its surface. Okay, now the adsorbate is adsorbed on the adsorbent. Okay, now you look at the figure like here. Okay, so before adsorption, the molecule in all directions. So what happened to the disorder gas? The disorder gas increases because the molecule is not in an ordered way. So disorderness, or you can say randomness. Randomness. Okay, disorderness or randomness, that should be increases. But whenever if you take a adsorbent after absorption, the reaction is over after absorption. Now you look at the second figure where the adsorbate is going to be absorbed on the surface. Okay. Now what happened to the disorderness? The disorderness, that should be decreases. Why? Orderness is increases because all the molecules is arranged in a water in a regular way. So the disorderness decreases. Whenever the disorderness decreases, the del S value, that should be negative, because what is del S? Del S is nothing but change in entropy. What is entropy? Entropy is nothing but it's a measure of degree of disorderness or a randomness in a molecule. So this is change in entropy. So what is entropy? Entropy is a measure of what? Orderness, that is disorderness. So it's a measure of disorderness. Disorderness. It's a measure of disorderness. Okay. Now, characteristic of adsorption, I explain three concepts. Whenever the bond is formed, okay, whenever the bond is formed, during the bond formation, energy has to be released. That released energy is going to be converted into heat. Okay, so because the energy is released in the form of heat, so we name it as this type of adsorption reaction comes under a exothermic reaction. Okay, so by exothermic reaction means we just given that expression. What is del H? What is del H? Change in enthalpy. The change in enthalpy should have what value? Negative value. Change in enthalpy, what value? Negative value. Okay. And second point, we are talking about the spontaneous. We are talking about the spontaneous. If you take a absorption reaction, this is surface phenomenon. Whenever absorption is taking place, this is a spontaneous process. For spontaneous process, the change in free energy value that is given a negative value. So del G should be negative. So if you take the third one, if you talk about the disorderness, before absorption, the disorderness will be increases. The disorderness will be increases, but after absorption, if you take water after absorption, the disorderness it should be decreases. So the del S value, del S is nothing but what? Change in entropy, that is change in entropy, is a measure of disorderness in a molecule. That is also negative. So if you take the condition for absorption, del H value negative, del G value negative, del S value should be also negative. Should also be negative. This is a condition for absorption. Okay, and we know that from the mathematical relation, that is the Gibbs free energy. Okay, del G is nothing but del H minus T del S. Okay, del H minus T del S. Okay, so this is a mathematical expression to give a relation between the free energy, enthalpy change, and the entropy change. This is also a mathematical expression of relating all those things. Okay, now listen. Today we have discussed only the concepts. Okay, only the concepts. So what is surface chemistry? Phenomena occurs at the surface or an interface. Phenomena occur at the surface or an interface. Okay. So when you talk about a substance like solid, liquid, and gases, okay, those properties can be well explained on the basis of the nature of a surface. Okay, and what is called an interface? This should be represented by separating the bulk phases. Okay, we know that bulk means inside the medium and the surface means outer. So separating the bulk phases by using a simple dash by or like this or slash like this. Okay, slash. And what is absorption? So we know that just I'm giving that what is absorption. Taking an example of custard and the chalk piece powder. When you look at that, the chalk piece powder will be presented over the surface of a tester. Okay, it is not moving inside. Okay, it is not moving inside. So it is not penetrating. Okay, so it is not penetrating. Here, just I am showing the arrow mark penetrating, but the surface is not penetrating. So next step, absorption. If you take an absorption, I'm taking an example, taking a sponge and water. So when you dip the sponge into the water molecule will be absorbed by using of a sponge. Okay, and whenever this will be absorbed by using of the sponge means it's a bulk phenomena, and all the water molecule will be penetrating into the sponge. So this is a absorption phenomena. And the same way, if you take sorption, if you take a sorption, okay, so sorption means we know that okay, if you take that sorption, both absorption and the absorption will be taking place. And if you take a chalkers, it is dipped into the ink solution. You know that ink is containing water and dye. Both will be water will be absorbed and dye will be water absorbed. So both phenomena, absorption and absorption, is taking place. So this is an example for absorption. Okay, and wave absorption is a what phenomena? It is a surface phenomena. We are talking about two things. One is absorbent, and another one is the absorbate. So absorbent means substance. It is a solid surface. So any material that is going to be absorbed, that is called as absorbent. So what are all the material we can use means silica gel, metals like platinum, palladium, copper we can use. And same way absorbate also I gave an example. And next just we have explained what is the mechanism for absorption. And I gave a characteristic of absorption. There I explained three concepts. Okay. Now if you have any doubt, you can ask. Students, now can you hear me? Can you hear me? Can you hear me? All are here?
Students, am I audible?
Can you hear me?
Yes,
No?
ma'am.
Yes, okay. You have any doubt in absorption? Today I have explained only absorb. What is absorption? Two effect only, absorbent and absorbent. Any doubt in that? Say yes or no?
No, ma'am.
No, no doubt. Shall I ask question? Can you answer me? For that no answer, huh? Students, are you in the class?
Yes, ma'am.
Okay. What happened to the del H value during absorption? During absorption, what happened to the del H value? Whether it is positive value or negative value? Negative value.
Negative value.
Negative value. What happened to the entropy? That is del S value. Del S.
Negative.
Negative. Good. What happened to the free energy? Del C value?
Negative.
Negative. Okay. So can you relate all this del G, del H, and del S value by using of one formula? Can you say what formula you can use it?
Del G equal to del H minus T del S.
Del G equal to del H minus T
Del H
del
minus
S.
T del S. Good. Good. So you are listening to the class. Okay, very nice. And tomorrow also I'm going to continue the same topic. Okay, absorption. Okay, if you have any doubt, you kindly go through your book, and tomorrow you can ask. Shall we close the class?
Yes, ma'am.
Okay. Thank you.
Good morning, students. Students, am I audible? Dear students, we are going to discuss very interesting topic today. That is GFP. GFP means grain fluorescent protein. Actually, it is a protein which is derived from one of the jellyfish, that is Aquaria Victoria. Right? What is GFA? G stands for green and F stands for fluorescent. And P stands for protein. Actually, what is it? It is a tool which is used as a biosensor in biology. Right? What is it? It is a tool that can be used as a biological tool. Which is obtained from one of the organisms, that is a jellyfish, right? That is called simply Aquaria. Aquaria Victoria. So it is nothing but it is a kind of jellyfish, right? This is a first jellyfish to be isolated GFP. It's a protein that is first isolated from the jellyfish, namely Aquaria Victoria. It is a kind of jellyfish, right, students? My dear students, would you like to see the structure of Aquaria Victoria? Students, first of all, am I audible? Dear students, okay, no problem. So what is it? It is a biological tool, right? Simply I can say it is an excellent tool which is widely used in the field of biology. For what means to make a sensor, that is a biosensor. It is to act as a biosensor, my dear student. It is to act as a biosensor. Now, what is the role of biosensor in the world? Is simply it is to report the expression of particular metabolic activities of the cell, right? Hence, it is used as a reporter of expression. Simply, I can say it can be used as an excellent tool in genetically modified organism in order to act as a biosensor, or simply it is used for reporter of expression. Actually, it is a public question. Dear students, my dear students, did you understand about GFP? And nobody is going to answer.
Yes, sir.
What is it? I'm asking so many times, but nobody is answered any question, right? What is the abbreviation of GFP?
Green fluorescent protein.
Green fluorescent.
What is it? It is a biological tool, right? Where it is obtained? It was first isolated from the jellyfish, right? That is called Aquaria Victoria.
Aquaria Victoria.
Victoria.
Very good. So what is the use of this? It is to act as a biosensor.
Biosensor.
Biosensors.
Not only that, it is also used as a reporter of
Reporter of
Expression.
Okay, then exactly when it is exposed. Before that, I should introduce GFE. Then why it is seem to be like a green in color due to presence of simply I can say this green fluorescent protein. It consists of simply I can say some amino acids. How many amino acids are there? There are 238 amino acids. What are they? They are the amino acids. Yes, student, kindly cooperate. Then only you can understand the topic, right? So here you find there are 238 amino acids, right? Simply I can say all the amino acids. So the residues, almost we have seen 238 amino acids, the residues, right? Simply its weight is almost I think I can say, right? 26.9 kilodalton, right? It is a weight. That's why it seems to be like a bright green in color. When it is exposed by the student, when it is exposed to Bluetooth, right? It is going to be exhibited green in color when we expose these protein to blue color to, right? Ultraviolet rays, UV, in the wavelength of, right, 395 nanometer. So in between this, when the GFE is exposed to blue to ultraviolet rays, it is going to be exhibited green in color, right? So such a biosensor or such a, it is to act as a reporter of expression, right? My dear student, it is a reporter of expression. Okay, so there is a gene which controls such a protein. It is called simply, there is a protein. The name of the protein is nothing but GFP. So these genes are responsible. Green fluorescent protein is produced by the action of a gene that is called the GFP gene. Simply, these genes are which plays a very important role in genetically modified microorganisms, right? In order to exhibit such a protein, this protein to act as a biosensor, right? It is also known as simply reporter of expression in the cells of genetically modified organism, right? So this is simply something about GFE. In addition to that, is a GFE. So simply it is having the ability to form the internal chromatophore. Please understand, dear students, please understand, it is having ability, right? It is having ability to form internal chromatophore. Internal chromatophore. Internal chromatophore. That's why it can be used as a reporter of expression, right? I repeat once again. This is a green fluorescent protein. It is having ability or capacity to form an internal chromatophore in the cells of genetically modified organism. So that's why it is able to make a sensor that is called the biosensor. please understand why it is used to make biosensor, because it is having ability to form an internal chromatophore in the cells of genetically microorganism, right? So that is genetically modified microorganism. That's why it is used as a reporter of expression, or it is also used as a biosensor to make biosensor in the field of biology, right? So definitely from the content you can expect a question, right? Please understand, my dear student, right? So this is simply something but of GFP. I repeat it again. GFP is nothing but, dear students, will you cooperate? It is a green fluorescent protein, and it is also used as an excellent tool because it is having capacity to form an internal chromatophore in the cells of genetically modified microorganism. And not only that, it is also used for making reporter of expression. And that's why the genetically modified, the green fluorescent protein G, it is also used for making the microorganism or like a biosensor, right? Then it was first isolated from the jellyfish, namely Aquaria victoria. Then when it is exposed to blue to ultraviolet rays at the wavelength of 395 nanometer, it is going to be exhibited green in color, right? Due to presence of 238 amino acids. Its residues of fresh weight is 26.9 kilodalton, right? So this is simply something what of GFP. Students, may I ask you some question?
Yes, sir.
How many amino acids are present in G?
238.
238 amino acids.
Very good. Then could you mention the fresh weight of GFP? Could you mention its fresh weight? Here I have given a weight, that is a 26.9. Then what is used as a reporter of expression?
GFP gene.
Right. Very good. Then could you mention the wavelength which is applied in when we use GFP, right? Could you mention the wavelength?
395 nanometer.
Very good. Will you mention the color? Blue to?
Ultraviolet.
Ultraviolet.
Very good. Very good. It is also used as a tool, right? Once again, will you mention the name of the fish, jellyfish? From that?
Aquaria victoria.
Very good. Do you like to see the structure of the Aquaria victoria?
Yes, sir.
Right, let me show you, right? This is a very interesting topic, my dear students. You can understand, right? So this is a jellyfish, right? I think it is a green in color, right, my dear students? It is very interesting area, right? Because from the content you can expect both questions. One of the question was asked previously, which of the following is known as a reporter of expression? That is the question, right? This is a structure of a jellyfish, right? There is a jellyfish, it is exposed to, the GFP, green fluorescent protein. When it is exposed to blue to ultraviolet rays at the wavelength of 395 nanometer, it exhibits green color, right? So this is the nature of a GFP, right? My dear student, so simply it's a jellyfish. Please understand, right? Shall we move for next topic?
Yes, sir.
Very good, right? Hoping that the topic has been reached on you, right? So next we pass on to bioforming. Next topic is bioforming. Pharmaceutical substances or pharmaceutical product are obtained by using of certain microorganism in a transgenic plants, right? So successfully we have developed many transgenic plants by using of certain microorganism sustainable, some pharmaceutical for mankind, for a human being. They are called as simply bioforming. So bioforming is nothing but the answer is hidden in the title. Bio means biological sources. Forming means a pharmaceutical product like antibiotics, tablets, or injection, etc. Right? So all the antibiotics or all the biological sources are simply which are essential for mankind. They are obtained by using of certain microorganisms. They are called as a bioforming. It is also known as bioforming. It is also called as simply I can say molecular forming. Molecular forming. Bioforming, it is also known as a molecular forming. Then molecular forming, it is also called as a forming. Okay, what we are going to obtain from this bioforming? The pharmaceutical substances. Pharmaceutical substances are obtained, right, from the plant. So that is called as a bioforming, right? So bioforming, the simply I can say the use of genetically modified microorganism, right, for making this sustainable product like pharmaceutical substances. So that's why it is called. It is also known as a molecular forming or simply pharmaceutical substance or forming. And one more thing, just I'm going to show you, right, my dear students. So in that bioreactor, which gains more and its cost, expensive is very less, right, dear students? In that bioreactor, which gains more, right? Bioreactor which gains more, and it also plays an important role in the department of pharmaceutical, right? So because this bioreactor is widely used for making the pharmaceutical substances, right? So that is very important. The expense is very less. Its expensive is very less, and the sustainable is more. Please understand, my dear students. Because this bioreactor, which is greatly gained, right, from bioforming, so it's a sustainable is more. Sustainable more and expensive is less, right? So that is a nature of bioforming. Simply bio means biological sources, forming means pharmaceutical. So simply these pharmaceuticals are obtained or derived from the genetically modified organism, right? So in which bioreactor which gains more and its expense is very less and sustainable is more. Please understand, right? Okay, I'm going to give an example for this, right? I'd like to give an example for bioforming golden rice. Because this golden rice is a genetically modified organism in which vitamin A, the gene of vitamin A is inserted. I'm talking about golden rice. It is a genetically modified one in which, dear students, vitamin A So this deficiency of vitamin A is fulfilled by the insertion of carotenoid. Actually, carotene, the gene of carotene is extracted from the daffodil plant and inserted into paddy plant. So that's why this food, the rice which gets more amount of vitamin A. Now this vitamin A, generally the deficiency of vitamin A causes a night blindness, particularly I can say in children. So this night blindness is totally eradicated by insertion of the gene of carotenoid into this genetically modified, I can say, in rice. So this is the rice after insertion of the gene of vitamin A into rice field, the rice which got the power for producing more amount of vitamin A. Now the deficiency of vitamin A causes no blindness nowadays because the gene of vitamin A is inserted and the vitamin A is enriched by the insertion of the gene of carotenoid, which is extracted from a daffodil plant and inserted into Oryza sativa, in rice field. That's why this golden rice is a suitable example for bioforming because these pharmaceutical substances are produced by using this bioreactor, right? So this is simply something about bioforming. Dear students, would you like to give an example for bioforming? I have given an example. Could you mention the example of bioforming? Yes, students.
Golden rice.
Golden rice. Very good. Golden rice is a right example. Already you have studied about what is golden rice and what are the types of genes are inserted, right? So because the insertion of this foreign gene or DNA for making of vitamin A artificially, right? Already you have studied. Right. Okay, let us continue. And one more topic, that is bioremediation. Bioremediation. What is bioremediation? Actually, bioremediation is a process by which remediation of environmental pollution. I repeat once again. Bio means a biological sources, right? In which the environmental pollutions are remediated. What is a remediator? What is the meaning of remediation? Simply the use of living organism to degrade environmental pollution, that is called bioremediation. Dear students, please understand, bio means a biological source. Simply I can say the use of living microorganism. So simply the use of living organism. Living organism. For what? For degradation of environmental pollutants or pollution, right? Simply I can say it is defined as the use of living microorganism or macroorganism into the atmosphere or into the environmental, right? Environmental condition to degrade environmental pollution or pollutants, right? That is called as a bioremediation, right? Okay, the use of living microorganism, it may be either plants or some microorganism or fungi or some rhizosphere or any other. So simply the use of living organism, it may be micro or macroorganism for degradation of environmental pollution. So simply the environmental pollution can be remediated by the action of certain microorganism can be introduced into the atmosphere. So that is called as a bioremediation. Just imagine, now this is a plant, now this is a area, right? This is a place where you find Simply I'd like to draw the structure of globe, right? It is a globe. If it is contaminated, right? What will happen is we have to degrade the pollution. If this globe which is contaminated by soil pollution or air pollution and so on, so right. So this polluted atmosphere or this polluted environment is degraded by using a certain microorganism or some plant or some fungus that is called a bioremediation. Simply I can say bioremediation, it is a technology, right? I can say it is a technology that has a great potential to degrade environmental pollution or pollutants. You should understand, my dear students, pollutants and pollution. Pollutants, or it may be either gaseous or liquid or solid substances, they may cause a pollution. They are called pollutant. Please understand. Pollutant. What do you mean by pollutant? Any substances, either it may be either gas. Pollutant. What do you mean by pollutant? Pollutant, it's nothing but any substances, it may be gas or solid or liquid, right? It is going to cause pollution to the environment, that is called a pollutant. I repeat it again, any substances which is going to cause pollution to the environment, that is called a pollutant. It may be either gas or it is in the form of solid or it is in the form of liquid. Now these environmental pollutants are totally eradicated, totally degraded by using a living organism, that is called a bioremediation. That's why I said in the beginning, the use of living microorganism which has a great potential to degrade pollutants in the environment, that is called the bioremediation. Because these environmental pollutants are degraded or remediated by using some microorganism or some macroorganism or plants or some other, right? It may be either by micro or macro living organism, that is called a bioremediation, right? So in order to understand, I'm going to show you. Simply I can say, dear students, just imagine now it is a globe which is a green in color, right? So in order to create the polluted atmosphere into green portion, right? Just imagine, my dear students, nowadays we are using a lot of plastics, all the what we are using, all these substances or products which are going to contaminate our surroundings, right? So our surrounding is contaminated by throwing off some unwanted materials like plastics, or when we cultivate any other craft in the field, so the land which is going to be contaminated, right? So when we manufacture any products from the industry which release more amount of effluents, these effluents are also going to contaminate this atmosphere or this environment. So such a wastage which is going to be degraded, or it is to be cleaned by using of some organism, either by plants or by bacteria or by fungi or by using of yeast. These environmental wastage which are going to be degraded. So such a condition, such a technology is known as a bioremediation, right? So simply the use of plants to degrade pollutant, or the use of living microorganism, particularly against a bacteria, to prevent pollution or to degrade environmental pollutants or pollution, or sometimes the use of fungi which brings about the remediation of simply degradation of environmental pollution, or waste which brings about remediation to the environmental condition. It is also known as simply bioremediation. Dear students, hoping that you could understand right what I mean by bioremediation. So next we pass on to what are the simply what are the strategies of the bioremediation, right? Strategies of bioremediation, my dear students. What are the strategies? So the first of all, the first point is the use of indigenousness. Indigenous microorganism, right? It is also used as simply the use of indigenous microorganism, right? These microorganisms are used to prevent pollution. Particularly, I can say the Pseudomonas purina, one of the bacteria which is widely used to clean off this ocean water or sea water. If any leakage from the ship, a ship containing simply oil tank, unfortunately, if oil is leaked out from the tank into sea, what will happen? The place where in sea the ship is floating, the leakage of oil slick which spreads out around the ship. So now that place is contaminated by the introduction of simply oil slick. Now, this oil slick can be remediated by using of certain microorganisms, right? So that is one of the strategies. Second thing, right? So sometimes the microbial inoculants are also designed in order to prevent pollution, right? Microbial inoculant. The microbial inoculants or artificially made or microbial inoculants are designed for the growth of microorganisms. So that is also one of these strategies, right? And the third, so there are only 3 stages of strategies. The use of simply plants. The use of some living organism, right? Like microorganism like a fungus or some bacteria, so etc. So the use of these living microorganisms which are to be introduced as a genetically modified organism, because these are contaminated or the use of a living microorganism, it is also used for making this wasteland or this contaminated area or the contaminated site in order to make it, in order to transfer, right? Like a green portion, like a green land. What is the difference between wasteland or contaminated land to green land? The place where you can see large amount of pollution or pollutants or degraded area, right? These waste which are contaminated, the waste are found in a place that is called a polluted land. Now, this is a polluted land, it is to be remediated by using of certain microorganisms. Hence, this is a polluted waste land is remediated as simply green land. That means the polluted area, it is to be filtered, it is to be clean, it is to be degraded into clean land, that is called the green land, right? So that is a strategy of a bioremediation, right? Now, as I said, bioremediation, it is of several types. There are so many types of them, my dear students. Bioremediation, it is of several types. Now this bioremediation is of several types. I'd like to mention few types, right? Dear students, you can understand. I'm talking about there are so many types of the bioremediation. As I said, it is a technology that brings about environmental degradation. Simply, it brings about environmental degradation, right, from the contaminated site. So it is broadly divided into following types. The first type is, it is classified into so many types. So let me take the first type is phytoremediation. Yes, students, please understand. I'm talking about the first category, that is a phytoremediation. Phytoremediation is nothing but phyto means plant, remediation means the remediation of environmental pollution. Here, just to separate. Phyto means plants. The use of plants, simply a use of plant which brings about remediation. I mean environmental remediation. That is called phytoremediation. Dear students, please understand. Phytoremediation is nothing but phytoremediation is a process by which the use of plant which brings about remediation, right? That is called from the contaminated site. I mean, the environmental pollution is degraded by using a plant, that is called phytoremediation, in which plants are involved, right? Simply I can say the use of plant. As I said already, what is bioremediation? Bioremediation is a process by which the use of living organism to degrade or to prevent pollution or environmental pollutant, that is called bioremediation. Here we are going to discuss a number of types. The first type is a phytoremediation. Phytoremediation is a type of bioremediation in which the use of plants which brings about simply remediation of environmental pollution, right? So as a result, the polluted land, it is to be made as a green land, right? Or clean land, that is called the phytoremediation, in which green land which plays very important role, right? So next, let me take a second type, that is a mycoremediation. I'm talking about second type, that is mycology. The study of mycology is called fungi. So mycoremediation. Simply, mycoremediation is another type of bioremediation in which the use of some fungus, right? The use of fungi which brings about remediation of environmental pollution into clean land, that is called the mycoremediation. Dear student, please understand, myco means fungus and remediation means cleaning of wastewater, right? Waste land, right? Or contaminated site, it is to be made clean. That is called the mycoremediation. Simply I can say the use of fungi which brings about remediation from the contaminated site into clean land. That is called the mycoremediation. The third type is, simply I can say, bio-venting type. Third type is a bio-venting. Now, bio-venting is a process in which the oxygen level or O2 level is increased, right? If the contaminated site in which carbon dioxide or other gases are also occupied, in that area, when we introduce a more amount of oxygen by planting trees, right? So it increases oxygen level or airflow. Simply, airflow is gradually increased, right? by the process that is called bioventing. Ventilation, releasing or introducing or making or production of oxygen, right? So simply the oxygen level is increased in contaminated area of the environment, right? That is called bioventing. So simply try to increase the flow of oxygen in contaminated site. That is called the bioventing. Sometimes, dear students, you can expect what is bioventing? Bioventing is a process by which increasing amount of oxygen or increased level of oxygen in contaminated site, that is called the bioventing. This is one of the way by which the contaminated site can be made clean, right? So please understand. Next, fourth type. Let me take fourth type. The fourth type of bioremediation is bioleaching, right? Dear students, we are going to discuss about a number of bioremediation, right? Bioleaching. Actually, they selected some metals. Simply, bioleaching is a process by which, simply I can say, the removal of or recover of metal or removal of heavy metal from the content. Simply, it is to recover the metals which are found in a contaminated area, or simply bioleaching is a process in which removal of heavy metals which are contaminated in a particular area, that is called simply bioleaching. So bioleaching is a process by which removal of heavy metal or recover of heavy metal from the contaminated site, right? So as a result, we can get, after removal of metal from the atmosphere, what will happen? The land or the area which is going to become like a clean land. So it is also known as bioleaching. Bioleaching, recover of some metal or heavy metal in the polluted land, in the polluted site. So that is called bioleaching. Now, one more thing is bioaugmentation, right? It is very interesting area, my dear student. I'm talking about fifth one, bioaugmentation. So the fifth one is the bioaugmentation is a process by which simply the solid substances or any other unwanted heavy metals like a solid metals are also removed. That is a bioaugmentation. So bioaugmentation is a process by which the solid materials or the unwanted substances are also increased. Simply I can say it is a process by which the degradation process, it is to speed up. Bioaugmentation is a process by which the degradation process, it is to be speed up, simply to speed up. The process of removal of solid substances or solid material which are contaminated site. In that site, degradation is taking place by using up certain microorganisms. So these bioremediation, it is to be increased, or the rate of speed is gradually increased. So that is called the bioaugmentation. Simply I can say, to speed of degradation process in contaminated site, right? That is called the bioaugmentation. I repeat once again, bioaugmentation is a process by which degradation process or rate of degradation process which is increased, right? So simply to speed up the degradation process, I mean the cleaning of waste materials from the contaminated site. It is to be speed up. It is to be increased in speed, rate of speed, right? So that is called the bioaugmentation, right? And the next type is rhizofiltration. Dear students, one more type is that is a rhizofiltration. I'm talking about the sixth type. Rhizofiltration. Rhizofiltration means the use of a microorganism in the rhizosphere, right? If you take a plant from the root portion, now this is the root portion. Dear students, you can understand. I'm talking about rhizofiltration. Rhizofiltration means now this is a root in which we find soil is there, right? Here, my dear students, soil is there. And in between root and soil, there is an atmosphere that is called rhizosphere. Here, rhizosphere, this is a rhizosphere, right? Rhizosphere, it is an atmosphere which is found in between microorganism and the plant root. Rhizo means root. Rhizoid, root. Rhizo means root, right? So the use of living microorganism to degrade the microorganism causes pollution or some unwanted materials or solid or gases or liquid waste substances are present in the root portion. So the microorganisms which are found just near or around the root system, which are going to degrade, which are going to clean, which are going to prevent the pollution. So that is called rhizofiltration. Dear students, you can understand. Rhizofiltration is a process of removal of environmental pollution in the rhizosphere, right? That is called rhizofiltration. Rhizofiltration is very interesting topic, right, many students? And one more thing, the rhizostimulation, right? I'm talking about seventh one, rhizostimulation. Rhizostimulation. The rhizostimulation is nothing but the growth of the living microorganism when we use to degrade pollution or environmental pollution. So that is called rhizostimulation. Rhizostimulation is nothing but the growth of the living microorganism which are involved in biodegradation or environmental degradation. This in the process of degradation, some microorganisms are involved. So the rate of growth of such organism are increased, right? So that is called a rhizostimulation, right? So rhizostimulation is nothing but it is a process by which the microorganisms are involved in that condition, which are going to be increased. So the rate of growth, the microorganisms which are involved in degradation or bioremediation process, which are going to be increased in its growth. That is called rhizostimulation. The last one is the compositing process. Dear students, please understand it is the 8th one, compositing. The compositing is nothing but the use of simply the solid substances which are going to cause pollution, right? Or the pollutant, the solid pollutant, simply can say the solid pollutants which are converted into usable nutrients, right? Usable nutrients. So that is called a compositing. A solid pollutants which are going to cause pollution. I mean the waste of animal and the waste of human being, right? Which are converted into nutrients which are used for plant growth and development, right? That is called the compositing. Actually, compositing is a process by which the solid pollutants are converted into the gaseous form of or liquid form of nutrients which are essential for the plant growth and development, right? That is called the compositing. So this is a simply types of bioremediation. I repeat it again. There are several types of that. The first one is a bioremediation, second one is a microremediation, third one is a bio-winding, fourth one is a bio-leaching, and fifth one is the bioaugmentation, and next rhizofiltration, and the seventh one is the rhizostimulation, and finally we discussed compositing. It is a process of conversion of solid pollutants into usable nutrient, right, to the plant growth and development. So that is called a bioremediation. Repeatedly I'm saying bioremediation, because it's a board question, right? You can expect in board examination. Define bioremediation. Once again, I'd like to define simply bioremediation is nothing but the use of a living organism to degrade pollution or to prevent pollution or environmental pollution, right? That is called a bioremediation. So as I now explained it, there are several types, right? Now, thank you for joining, my dear students. And when you come to next class, try to practice, try to prepare, read thoroughly all the questions, right? Which I have taught you, right? Now it's time for giving home assignment. Please stay back online, right? My dear students, last a few minutes, guys. Let me take only a few minutes only. Please take